Hey folks, welcome back. In this session, we're going to be having a look at how to use the accumulate field node to pack objects from a collection, right? Arbitrarily sized objects. What I've got here, what I'll be using for the tutorial is 4 models from our previous game jams. So huge props to the creators of these. Well, let's jump in here. I've just got those in their own collection. Let's have a look at the problem with the accumulate node. So this is your kind of default standard setup. You'll have something which is going to be probably in a 1 meter by 1 meter by 1 meter space, sort of unitized object, and you're going to be scaling it and using the accumulate node to offset 50% of that thing. This gives us a couple of issues. One, it requires all of your input objects to be scaled to 1 by 1 by 1. Not really practical. And it also requires us to have our origin positions, which is actually what this halfway between the leading and trailing value is doing. It requires you to have the origin positions in the center of whichever axis you're aligning in. In our case, we don't necessarily know that. So we're going to be building 3 tools. First one is going to be a collection info plus node. This will give us bounding box information per instance. We are then going to be taking that through an instance packer node we're going to make, which is going to be essentially a glorified accumulate field node that can take bounding box information and deal with that so that it does the correct packing. We're then going to be making a accumulate on curve node, which is just going to allow us to stack different sized objects along a spline. Essentially, it's pretty straightforward, but just a couple of extra nodes that you might not be aware of. So let's jump in here. The first thing we're going to be doing is a collection info plus. Let me just delete all this. And my setup is I have a plain object, which has no group input on the geometry nodes. So I've just essentially got a container for my geometry nodes, and I'm going to drag in my object info here. So I have my collection of objects. So let's go ahead. Let's just chuck this straight into a group. So when I do this, it's going to populate the front as well. Let's rename this one to collection info plus. Make sure we're saving, mark this one as an asset just so you've got it in the future. Let's tab back in. I actually do want separate and reset turned on so that we've got these, and I'll probably just make that the default setting here. So default on, and I'm also going to make sure that my collection picker has no default value. If you have a default and you link or append your node group to a new file, it will also append the collection that it is referencing. So make sure you get rid of that default. Now, what we're about to do requires a little bit of understanding of bounding boxes and also how instances work. But let's just start off with the bounding boxes here. Let's just do a preview. So I'm going to grab an icosphere. Let's go into solid view. And I'm going to put on a geometry bounding box node. So pretty straightforward so far. Let's have a look at the spreadsheet for this as well. So with the spreadsheet, we can have a look at the individual points, and obviously we're centered around the origin here. So what we can do is we can see that point 0 is the negative most point, and point 7 is the maximum, the most positive point. This is really important. All bounding boxes are created equal. So you always have the 0th point being the minimum point and the 7th point being the maximum point. All we need to do is make sure that essentially our collection of objects knows where the 0th and 7th point is per instance. So a little bit of data wrangling we're about to do. Let's go ahead and grab a attribute, capture attribute. Let's rename this one to min, just so that we know what we're doing. We're going to be capturing a vector because we're interested in the position. There we go. And why am I not plugging these just from the bounding box node themselves? Well, when you're dealing with instances, as you can see, these are circle sockets. So it's not a value per instance, it's just one value. In this case, it's going to read fine because it's coming from an individual object. If I plug from a collection and then hover over it, well, now it thinks it's 0, and that's clearly wrong. We can see it's wrong. So let's go ahead and go back here. We just need to capture a specific position from a specific index. Let's go ahead and use a utility field at index. We're interested in a vector on the point domain. Let's plug this through like this now. And if I just view this with a viewer node, that was Control Shift left click, then you can see If I just view the position directly, we have a different position per point. If I view the position through the capture, now every point is aware of where the position of index 0 is, right? So everyone is now the same. We can use this. Let's use another capture, rename this one to max this time. I'm going to Control Shift D on my field index, and I'm going to set this one to be the 7th index. So now we're capturing index 0 and capturing index 7 on every point. So now you can see we've got the negative most and the positive most points stored. Now all we need to do is actually just delete almost everything. So the point of this is going to become apparent when we want to transfer it back. So what I've got is a collection of objects up here, right? And we have 0, 1, 2, and 3 as our indexes. If I now want to transfer the information back from these, well, for a start, I need these to be realized. So step 1. Now I'm going to use a transfer attribute, which I'll be setting to index because I need to be transferring it per index, right? And there we go. We've just immediately run into the problem. Each one of these bounding boxes has 8 points, and that is going to offset our index transfer. If you're using Blender 3.4, what you're going to be using instead of the transfer attribute is the sample index. So 3.4 has split apart the transfer into its individual algorithms. So in this case, you'll want to be transferring a vector on the point domain by index, right? So yours will look like this instead, but otherwise, same process, essentially the same nodes. That's just for you if you're working in the future versions. So back in 3.3 here, when we're going to be doing our transfer, we need to make sure that we only have 1 point per bounding box. This is why we captured these positions on every single one of the vectors. So if I were to say, come in here with a delete geometry node, and let's just plug the index into it here. So I can plug this index in directly and just be left with 1 point because the index is 0, 1, 2, 3, 4. And if you pass that into a Boolean socket, then it's going to be read as no, yes, 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 yes. So you can just plug this one in directly and you'll just be left with the first point. We've captured everything everywhere, so that's fine. Then we can do our realize, and then we can transfer by index because we now have the correct number of points per instance. So let's go ahead and just capture from this transfer. I'm going to be capturing my minimum vector per instance now because we're working on instances, and we're going to be transferring that vector from the minimum socket across like this. Okay, so that's what this looks like. We've got our minimum coming across here like so into our transfer, and then that goes up into our capture for the instance domain. All right, let's do another one. Let's do our max. Plug this on in front of our minimum. Again, we're going to be changing this from point to instance, and I need another transfer. Control Shift D on there. This one is going to come instead from the maximum. So now we've got our transfers in place. Let's go ahead and plug this one up, and we can just plug this one into our group output as well. I will just make sure I'm naming these correctly. So min, the other one is max. And there we go. Are we done? Not quite. We still want to have not just our geometry coming out or our instances. If we're doing all of this for our bounding boxes, then let's pass those out as well. So I'm just going to take these from the max capture to my group output here. And I'm going to rename this one to bounding boxes, plural. And we also want this min and max to work on those because obviously these are captured on a geometry, which is not this. So all we actually need to do is add from these captures. So we can literally just use a vector math node. We're going to be adding the captured minimum from our bounding boxes to the captured minimum from our other geometry. So why does this work just using an add? Well, it's because they're in different domains and they're different geometry. So if you capture something and you try and read it on a different geometry, it will just read 0. So obviously when you add to that, you're just getting its original value. So you can essentially concatenate captured values like this. Just add them together. There we go. Sorry for the cross noodles. Hopefully that all made sense. And now we have our, make sure you're saving, collection info plus node. So the next step here is we're going to want to actually start working with this on our accumulate. So we're going to need a few things here. Let's just set up our basic setup again. We're going to use a points node. We are going to use a set position node like so. And we can just view this directly. That's fine. It'll be clear as we're working through if it's working or not. So the reason I'm using a set position rather than instancing these objects, which now have all of their captured information on, and then, manipulating that afterwards with like a instance, translate instances. The issue is that none of this information actually goes through the pipe when you instance it. Hopefully that is something that gets fixed in the future. All this means is that we just need to work on the points before. However, what I was just saying about us having captured our min-max on these instances, well, now this means that we need to transfer this from the instances to these points. Again, this is quite straightforward though. We're going to be using a transfer by index. So again, if you're in 3.4, you're just going to be using the sample index node instead. We're interested in transferring a vector. Let's just start off with a min. And then we also want to do another one to transfer the max, just like this. So fairly straightforward at this point. And we now want to work out the difference between them. So the reason I'm transferring min and max separately, and in fact, let me name these so we know what's what, is because we might want to do other things later. So I'm not just going to work out the size of it and transfer just the size. I'm going to transfer individual points. And then if we need to work with something at a different point, at a different speed later, then we can. And the one thing which jumps to mind is how we can manipulate it around the origins. We will come into that in more detail in just a moment. So how do you work out the size between two different vectors? Let's draw a quick grid here. So we've got a point here, which is going to be at 1, 1. And we've got a point here, which is going to be at 4, 3. So logically, we can see, okay, well, it's 3 by 2. But what's the maths to get there? Well, it's our maximum point subtract our minimum point, right? That's the calculation. So max subtract min. Let's go ahead, grab a vector math node, set to subtract, do this. This is now our size per instance. And then we can plug this into an accumulate node. We're working with vectors, so let's go ahead and just use vectors here. This is all fine. I mean, it might not seem very intuitive, or if you're not used to vectors, this might seem like a weird thing to do, but each channel, each X, Y, and Z channel of the vector is going to be treated individually. So accumulating vectors at the beginning, they're not going to kind of cross-contaminate. It means that you can still pull out a float at the end with a separate X, Y, Z, and it's going to work just fine. So again, we're going to take our halfway point for now. I'm going to be using a mix RGB. If you were using 3.4, you can be using a mix float. Again, I'm going to set this to 0.5. And then you could use a separate XYZ and then a combine XYZ and do this. Let's view the output. But there's a faster way of working here. Rather than separating and combining, you can just use a vector math node set to multiply and just put 1 in whichever channel you want to keep. So in this case, I want the y-axis. Let's keep the y-axis. And I will just plug this up into my position. Alrighty, so why has this not worked? It's not done anything. Take a sec, have a look at our nodes and just have a think about that. Why is this not working? Now the reason is that when you use a transfer attribute node, you need to be working on the domain that you're transferring from. So in this case, we're transferring from instances. In fact, maybe I go and rename this one just to be doubly clear. So instances come out of a collection info node. Therefore, these both need to be set to instance. All right, so I was just a little bit confused about why this was doing an even offset. Clearly looks pretty even as I go up here. I made a pretty significant error in here. I never plugged my collection info into the bounding boxes. That's all you have to do to make that work. Just make sure you have your collection info going through your bounding boxes. I left it all with the icosphere we were playing with to test it. So that's the only change. So now we can see that these are spaced out differently, which is awesome. So let's go ahead and just instance on points our collection info up into here, pick instances. Awesome. All right, look at these. These are kind of working. Kind of working. They are clearly offset by approximately the right amount. So why is this not perfect? Well, it's actually to do with the origin positions, because let's show our objects here. I'll move them off to the side. So everything is fairly, I don't know, it looks like it's fairly on the line here. But if you actually look at it, this one comes 1 meter down, but it's almost 2 meters up. This one comes 2.5 down, but it's almost 4 up, 3.5 up. Right, so these are clearly not centered. And that means that we need to make a correction per origin. This is one of the main reasons that we've kept these min-max values separate, because all we actually need to do is find the center point between them. So let's use another mix node here. Again, if you're in 3.4, use a mix factor. We're just mixing to a factor of 0.5, so halfway exactly. And all I'm going to be doing here is subtracting this sort of central origin off the positions. And there we go. Now we actually have these stacking. All right, looks awesome, but only for the first 4. So what's going on here? But let's go up to maybe 10 so we can really see this. Yeah, basically we get through these and they work correctly. And then for every subsequent one, what it's doing is it's using the last one. It's essentially repeating the last in the list. Well, this isn't quite what we want either. So we need to do a little bit of index manipulation on here. Let's go ahead. I'm just going to reroute this down here. Let's go ahead and plug our index node on like this. This index node is going to set us up now to be able to modulate. Modulo. We need to modulate by however many points we have in here. So we can give this a little bit of a test actually. If you're ever not sure, like, okay, what do I actually need to do here? Okay, so 3 is not working. Let's try 4. Okay, 4 looks like it's working. Why is 4 working? Well, if we hover over here, we can see there's 4 instances. So that can be your little like litmus test. You should always just have a few ideas about how you can test things. So where are we going to make sure we've got this number procedurally? Well, we have a domain size node. Let's go ahead and plug in an instances count like this. So there we go. Now this is always going to be correct per number of instances. Before we go any further, I want to put this into a node group just to make sure that we can keep things a little bit more controlled. This is a good time to do it. So just up to the subtract so that we're passing out the length as a vector here. So let's jump these together, Control G, like so. I'm going to just tab out real quick here, call this one instance packer. There we go. Make sure you mark it as an asset because this is something you're going to want to use in the future. And I can now condense my node tree a little bit, make it a little bit more usable. There we go. So instance packing. This source we want to put up to the top. These are going to be our instances. And our first one here is going to be the min. In this case, just make sure you're checking which one you're plugged into. And my other one is the max. And there we go. So the next thing that we're going to want to do here is, well, what happens if you want to randomly change these? So right now it works fine. If you just want like a straight array of everything and it's exactly the same size and they're in a repeating order, you're golden. You got it exactly what you want. However, sometimes you want things to be a little bit different. So what we're going to do is what happens if we have a random value in our instance index up here on the instance on points. Well, now we have this issue where we have all of these using their original positions. They've been picked in order and we're shuffling them later, which means that they no longer fit correctly. So we need to have a way to plug our instance index value into our instance packer and have it behave correctly. Let's go ahead and add a new socket on here, which I'm going to change to an integer. I'm going to rename this one to instance index, just to match our instance on points node. And again, just to match it, I'm going to hide the value. If I plug this now into my modulo, like so, there we go. I'm just trying to keep this relatively readable. So if I plug that instance index into our modulo, and now I plug that random value in, well, there we go. Now we fixed it. We fixed our offsetting to work correctly. It just has to be in two places. But now if I undo this, well, now it doesn't work at all, because now it's reading, oh, well, every single one of these instances is coming through as a 0, which means it's always going to use the size of, in this case, the minecart. Everything is now broken again. So we want a little bit of a safeguard here. Just for a sec, I'm going to turn off that hide value, and I'm going to set my instance index to minus 9,000 or 90,000. Yeah, let's go with 90,000, why not? Just basically an arbitrarily small number in the negative space. Indices are rarely, if you're working correctly, negatives. So we can be kind of safe in basically saying this random number that's way down there, that's going to be our default value. I'm going to put this also into the default socket. So it's kind of a janky way of working, but it works. I couldn't just say if it equals 0, then use the index, because it's often going to equal 0. So let's go ahead and shift A. We are going to now use a compare node. On here, we're interested in comparing the integer. From here, find out if it is equal to minus 90,000. And I'm going to use this as a switch node now. So let's go ahead and plug this into a switch, into the top of the switch. Let me just stack these. And basically, we want these to be integers. So we can basically say, if this does equal minus 9,000, which is the default value, then you should use the index by default. If it doesn't equal minus 90,000, then that means that you've plugged something into it. And in that case, you should use the instance index that you've plugged in. And then I can just plug this out like this. There we go. All right, so this is our kind of, it's ugly, but it works. But it allows us to essentially say, is there anything plugged in? So I'm going to rehide that value. Now you can see that we have it working, repeating on our instances. Tab back out. If I plug in my random value now, and we just need to plug our random value into the instance index up here as well. There we go, just to make sure it's in two places. So now if I just mute them to turn them both off, we've got the index, that works. And now we have the random value, that still works. All right, so now we have the option to randomize our indices. So there's a little bit more that we need to do here just to make this properly useful. So on our output, let's make sure that we are outputting, let's just call this one length. That's essentially what we're doing here. Calculating the length along that we should be doing with these. And we have a little bit more that we want. Let's go a little bit further with our randomizing. Let's grab a random value. I'll go for a float, and I will plug this into my scale. Well, all right then. Some of these have got smaller. Obviously, the packing has not changed. So let's also allow us to do random scale in our instance packer. So in here, we want to add another input socket this time because I want a special socket. I want to basically match the instance on points node. So I'm going to plug this one into the scale there just to make sure that I've got the correct format with this XYZ. And that is all fine. Default of 1, that's perfect. Okay, so in this case, we want to plug through our random value as well, just so we've got that coming in. And because this is getting a little bit congested, I want to make sure that I'm framing stuff so that we know what it is. Let's go Control J on these first sections and call this one index control. And then I'm going to be duplicating my group input up here because we now want to be working with this just in front here. So after we've worked out the size of our object, we want to scale it. We want to simply multiply this by some value. Now that's worked pretty good, but not perfectly. Not perfectly. And why has it not worked perfectly? It's because of our origin offsets. Just going to hide that, Control H. So the origin offset has not been fixed. We're still offsetting by the full size version. So in this case, what I want to do is take my multiply, and I'm going to do it over here as well after this bottom mix, again with our group inputs. And there we go. All right, and now we have scale control. It's looking pretty good. There's one more thing that we might want to add here, and that would be something like spacing. If everything was going to be this bag, for example, let's, instead of using this instance index as a random value, I'm going to just use an integer input. And now let's go for the bags. There they are. So we might want to add spacing. Basically, I might want to say, let's have a meter between each point. Or maybe you want to overlap stuff a certain amount. If you're doing something like dragon scales, you might want to actually have them slide up over. So in this case, what I'm going to do is Shift A. We want to use a vector math node set to add. On my group input here, Control H, I want another socket for spacing. This one, I'm going to use a grid, and I'm going to steal this size, which I will default to 0. So there we go. Now, the reason I'm doing this is just because I want that meters value there. So let's go ahead and just add this value like so. And this happens before the accumulate field. Essentially what we're doing is we're saying this thing is this much larger than you're saying you are. I don't need to do anything with my origin offsets or anything like that. This should work fine. We're essentially adding it to one end. And if I now change my spacing, there you go. Now we can make this bigger. But we have a soft limit. We have a 0 soft limit. Let's make sure that we're going down to something low. I'm just going to go for minus and then a lot of 9s. So now I can also pack it in a negative direction. If you want overlap, I'm going to set that back to 0. Don't really need that by default there. Is there anything else we're going to want to do here? The answer is, of course, yes. So we haven't even got onto the quality of life things yet, but just for now, as we're working through, what happens if you want to flip some of these bags around? Well, if I have my instance on points node here, I'm just going to switch, vector switch here, between 0 and pi. So now you can see if I flip these, they all get spun around. Here's an issue. We've got a little bit of an issue with these offsetting now. This is because our origin is not centered. So the point that these are actually spinning around is not in the middle. So we also need to make sure that we're telling the instance packer that you need to flip these specific objects. Let's go ahead and I'm going to do a random value just as a Boolean here. You can see this spacing and the overlaps. That's sort of good. And then in our instance packer, what we want to do is this origin offset section. I'm going to add a scale. So I can basically say scale it by 1 or -1 to go in the opposite direction. So this is going to be, again, on a switch. Let's go ahead and set one of these to 1 and maybe -1. And then I just need to make sure that I have this Boolean coming through from the outside here. Like this. There we go. Okay, that worked perfectly. So in this case, true is rotated and therefore true is scaled to -1. Let's just frame these up. I'm going to collapse that, Control H, Control J to frame, F2 to rename. This one is our origin correction. And I need to make sure that my switch input here is going to be called flip instances. There we go. Now, actual rotation, that is a bit more complicated. So again, if you're interested in rotating instances by a random amount, let me know down in the comments below, because doing a rotation takes another node. Essentially, if you want a hint, if you want to try this for yourself, to do a rotation per instance, you have to instance all of your instances and then do a bounding box for each one after it's been realized. And then you need to work out the size of that bounding box, which is now on a realized geometry instead of an instance geometry. So just a few extra steps in there. And then you can re-instance things based on this new information that you've got about the size of it based on its random rotation. There's a few extra steps. Again, let me know in the description if you want a tutorial on that. It's not difficult as much as it is just a lot of steps that you kind of have to know the way through. So there we go. This is pretty much, I mean, functionally, this is now complete, right, for our instance packing. The one thing I would like to do is make sure I'm passing things out. So you can see I've got everything splitting in 2 directions. Let's make sure that we're passing out the relevant information to make sure that we can just plug it through afterwards, essentially daisy chain, rather than doing all of this forking. I think it works a little bit nicer. Maybe we move the spacing down to the bottom here as well, and I'll hide the value on my flip instances. There we go. So there we go. That looks about right to me. Maybe flip instances also goes above scale. This is entirely up to you, but there we go. So now what I'm going to do is just make sure I'm plugging into the group output certain bits of information. Let me full screen this. I want to plug my instance index, which comes from this modulo. And actually, rather than plugging that one in directly, I'm going to steal the name and the type from the input and then plug it in. There we go. Keep this neat. We also want to plug through our scale. So I'm going to just duplicate our group input here. Control H to expand. And we can plug this one through like so. And I might also plug through my flip instances just to make sure that we've got it if we need it as well. And again, let's just make sure these are in the same order, front and back. There we go. So now I can just plug through these instances from here, like a thoroughfare, a little bit easier to work with. Our random value into that scale, well, that can now just go through directly. And the flip instances can also go through. So anything now that you want to control just happens in front of your instance backer. Well, what about more information? There's a bit more information that we have available that we might want to pass out of this node group for doing different types of transforms, different types of packing, what have you. So in this case, let's go ahead and make sure that we're doing all of our accumulate field. I'm going to need to do my subtraction to fix, basically based on our origin offset for the leading. Let's plug that one in and I will rename it to be leading. There we go. Let's move this one up to near the top. And I will do the same for trailing. Like this. Again, rename to trailing. We also want to plug out the total here, but this one does not need correcting because it's not like positional. So let's go ahead and just stick that one at the bottom. There we go. So now we have all of our accumulate information passed through, plus the length, which is generally the one you actually want. We can do another group input thing actually, because the accumulate field has a group index. So perhaps you might want to do a grouped accumulation based on a collection where you might have multiple splines or multiple different stacks of collected items. There you go. Now you can with this group index. So I'm going to hide the value on that as well on the front. We also might want to have our min and max values here for our actual bounding box per element after it's instanced, in case you ever need that information, and I have done in the past. So we also need to pass this out. How do we get a hold of it? Well, let's go ahead and just use our min and max values here, but they need to be scaled based on our scaling size. So again, we're going to take our multiply. We are going to be taking our minimum value, which is from the transfer. So it's already on the points that we're interested in. And then we can scale that by our scale value. So I'm going to just collapse that node, Control Shift D to duplicate with connections, and I'll plug the max into this bottom one. All right, so now we have our bounds min and our bounds max. And I can just plug these on to the bottom here. Let's rename these ones to min and max. Again, I'm just using the min and max values here just because if you ever do the lazy connection and you're using something like, I don't know, volume cube, like the reason that all of these have the same names, min max, rather than bounds min, bounds max, is so that you can do lazy connections because it will find similar named sockets. Last one we're going to do here is size. So not just min max, seeing as we've got it up here, that subtract does the size, the multiply does the scaled size. So let's just plug this one. We're not interested in it with the add for the spacing. So I'm just going to actually do this as size here. Maybe I put the one at the top of those three. Now, if you wanted, you could obviously rename these ones to like instant size or whatever if you want to be more explicit with it. But for now, I think this will do it. Let's tab out. You can see this is obviously a massive node, but that's fine. It's just information, right? You're packing instances, and therefore you might want different information depending on what you're doing. If I just Control H, I can collapse everything I'm not using. Think of this as just like a data kind of node. So, all right, now we have all of our objects stacking nicely. Okay, cool. Flipping nicely as well. What's next? Well, we want to be able to instance these along a spline. You might not just want these in a line like this. Maybe you want them in a spline. Let's go ahead and do that. Very simple process. Shift A. Let's grab ourselves a curve primitive Bezier segment. I'm just going to make this big with a transform node. Scale it up 20 times. There we go. Beautiful. So now what we want to do is we want to know where to position these points along this curve. And it's very easy. You just sample it. So there's a node, Shift A, curve, sample curve in here. We can set this to length. And as soon as it's length, that means that we can just use the length that we have from here, right? So I'm going to take our length, put it through a separate XYZ. I'm interested in the y-axis, just based on how things are aligned. And there we go. Now I can simply plug our position into the set position of this node. There we go, they're moving along nicely. Let's make these a little bit more organized. And as for rotation, we have from the sample curve, the curve tangent. And we can plug this into an align Euler to vector. And what you might be tempted to do is just plug this on in front of your switch into that tangent, into the Y. But now you have this issue where everything is going in the same direction because it's kind of ignored this previous switch. So you can see some of these, like this guy, should be flipped compared to this one. So we just need to make sure that instead of doing it this way, what we're going to be doing is, again, take that curve tangent into our vector, and we need to just rotate the Euler. So what we're going to do is use a rotate Euler. We can just drop this onto our switch, and we're doing a local rotation. So essentially we're taking the current rotations and adding to them. Now we can use our align Euler to vector in this rotate by. And now you can see these guys point in the opposite direction. They stack nicely like this. So we're still getting our proper packing. The tails make it a little bit confusing, but there we go. So now we can do our proper packing along a spline. There's one more safeguard we need to do here. Let me change this to a different object. Let's go for our minecart this time. And I want as many minecarts as I need to go along the whole spline here. So there we go. 78 is too many. But how do we know it's too many? Well, it's actually quite simple. We just need to delete geometry. We're deleting any point where the length from our accumulate is greater than the curve length. There we go. And we're using curve length, not spline length, because we're using a sample curve. So it needs to be on the curves, not the splines. The difference between a spline and a curve is that a curve is an assembly of splines. You can have dozens of splines and they will just be considered a curve object together. So in this case, we can take our greater than, plug that in up here. And there we go. If I mute and unmute, you can see we're just getting rid of anything that is after the end. So this delete geometry now removes every point where its position is further along the spline than the length of the spline. So it's just a nice little safeguard. All you got to do is just make sure that you have points that exceed the length of your spline. You could try and build something up here that would basically take your random value and the size of your objects and say, if it was all the smallest, what's the maximum number of points that we would need? But in this case, because we have the scale kind of coming into this instance packer, you can very quickly end up with circular dependencies. And so what I would recommend actually in this case is you just set it manually. You can always set it something really like insanely high up here, right? So if I set this to like 10,000, this doesn't take long to compute. We're not doing a large amount of computation here. So you can set this insanely high. I'm going to go with 1,000 actually, so that when you do your group, which we're about to do now, it's going to work correctly. So what do we need to make this into a useful group? I'm going to actually pull back my separate XYZ, and I'm just going to reroute that. I'm going to pull this down. All I want is this curve stuff up here. Control G to go into a group. This is all our length information. That is fine. And I actually want to get rid of this Bezier segment and transform. Let's just delete that and plug in from here. This is going to be our curve, which I'll move to the top. The reason I want that on the outside, obviously you might want different curves. And is that it? Maybe I'll just plug these points onto the front as well, just in case. And then in terms of the output, we have our points being output here. And I will also just put the position, tangent, and normal all on there just because it's information that I've got. So why not have it? And we're going to be renaming this node group to accumulate on curve. So this is all starting. I love using node groups. It just really compacts things down like this. So we do need to plug in a curve here. Let's go ahead. I'm going to use a curve spiral. There we go. Maybe we can make this a little bit bigger here. Let's go for maybe a 5 meter height and a larger start radius. There we go. Some of these are flipping over. Let's go ahead and just make sure that we're pivoting on the Z axis as we come around. And these are stacking nicely. These look great. Let's go ahead and just use our random value for the instance index here. Cool. Cool, cool, cool. Material preview. There we go. And there we have it. So what we've done so far in this session, thanks for sticking with it. I know it was a long one. We created our collection info plus. This is basically bounding boxes per collection info object. Super useful, but slightly more difficult to use than just plugging it through the instance on points node. So what we did was we created this instance packer node, which is essentially just the accumulate field with a little bit of extra maths to help us pack. Then the accumulate on curve node, which is essentially just a partner node or a companion node. Make sure you mark as an asset so you've got it for later. And then you can just plug through your length on here. So all good. And I like to do things where I can daisy chain stuff like this. So even if it's just a straight through connection like the flip instances or the scale, it just means that you don't have to cross noodles behind other stuff. So I can just daisy chain like so. And now we have a useful node. And there we have it. Hopefully this has been useful. I know quite a few people were asking about how you can accumulate stuff from a collection. And well, here's one of your answers. There's probably other ways, but this is how I do it. Hope you've had fun. Hope you've learned something. And I'll catch you on the next one.